Let's talk about bad designs from a manufacturing perspective. The following slides will discuss how these design factors play a part in design: economy, safety, functionality, and ethics. When a product uses a part multiple times, it is cheaper if the parts are all the same size. For example, when constructing furniture, using the same size screw for all connections is cheaper than using varying sizes. Another example would be manufacturers of some copiers have changed from metal parts to plastic parts because they're cheaper. Or a worker with experience and education may provide better quality work, but may also have a higher salary. In addition, something to consider when it comes to economy is that automation can reduce the amount of laborers needed to manufacture a product. Fast food restaurants offer toys in their meals for children. They must also offer an alternative to very young children, under the age of, let's say, 3, due to the small parts that could become choking hazards. Environment appropriateness includes water resistance, electrical compatibility, interference of other obstacles, etc. For example, the cup holders in a car should be placed an appropriate distance from the radio so that they do not interfere with the radio's operation. A clock that claims to be poolside implies that it may be weatherproof, when in fact it may only be weather resistant. Take a look at the toy on the right. It will work about 3 times. Then the inexpensive parts begin to show wear and tear. The seal on the canister breaks, the air tube pops out, or maybe the rocket holder breaks off. However, the cost was less than $1, and the toy would last for at least 1 birthday party. According to the Engineering Code of Ethics, engineers will uphold and advance the integrity, honor, and dignity of the engineering profession by the following things: using their knowledge and skill for the enhancement of human welfare, being honest and impartial with the public, their employers, and clients, striving to increase the competence and prestige of the engineering profession, and supporting the professional and technical societies of their disciplines. Consider these examples. Each one has a design flaw. Can you name them? Pause the video, see if you can figure out what they are. The stove controls are not arranged so that it's immediately obvious which control operates which burner. On this sink faucet, it's not obvious which way you should turn the handles to get the water flowing. Because both sides of the crash bars look identical, it's not very obvious which side of them you should push on to open the door. On this remote, the V's stand for volume, and at a quick glance, they look like directional arrows, both pointing down. Here are some more examples. Can you name all the flaws? Pause the video, take a moment. The letters on the caps are very small. In addition, arthritis is a common ailment among the elderly, and the cap here would be hard to grip. It's also difficult for some elderly to manage the motor skills necessary to open a bottle of something like aspirin. The handles for the refrigerator and freezer are built into the side. The designer thought it would look nice to create the same look on the other side. Maybe even make this door reversible. However, this can be confusing. These doors have handles. This implies you pull them to open them. However, the inner door must be pushed open. These doors are the entrance and exit for a glass walkway. People are often caught between the doors because they try to pull the doors open. Flaws in manufacturing always start at the design stage. If the designer uses the design process steps and utilizes market research and evaluation, many of these flaws can be avoided prior to manufacture. Now that we've seen some bad products, we'll critique some products currently at step 3, develop a solution. This design was intended to use the child's first initial as a handle. Problems include no lid, which defeats the purpose of a sippy cup, and there are sharp edges on the rim and handle. It's also difficult for small hands to grip this handle. One-piece design means that this will only fit one-size dog. Also, if the dog becomes caught on something, it can't get free easily. It will also be difficult to put on the dog. In addition, creation of these spikes as one piece is not feasible. This would have to be manufactured as separate pieces. This is one we've all had to deal with. For this USB drive, it could only be used if no other neighboring port was in use. This slide is intended for children ages 3 to 5. It would not be possible to create a slide like this all in one piece. The slide is unsafe. There's no sides to keep the children from falling off. The ladder is pretty much straight up. The top of the slide is too steep and the bottom ends abruptly. This toy is inappropriate for small children. Small parts could be swallowed. Also, storage seems to become an issue. Once the toys are placed inside, how do you get them out? Oh, this remote. It's not ergonomic. It doesn't fit the hands well. The buttons are arranged awkwardly. Joysticks are too short. The select and start buttons are unmarked. The gameplay buttons are uncovered. It just is not a good design. As you leave this video, consider products that you may have encountered in your everyday life that you feel have been affected by poor design considerations. Thanks for watching our video on bad designs from a manufacturing perspective.